In topic three, we're going to talk about quadrilaterals. So you have to remember, just kind of generically speaking, that a quadrilateral is a polygon with four sides. So any four-sided enclosed figure would be considered a quadrilateral. Okay? Now, what we need to know as far as like angles are concerned, when you're dealing with a quadrilateral, the four angles inside the quadrilateral, they're going to add up to 360 degrees. Okay? So the angles of the quadrilateral are going to have to be 360 degrees. And that should sort of make sense if you really like think about it. So like the most basic quadrilateral that we know would be that of a rectangle. Okay. Well, what's interesting about a rectangle is the angles are all perfect right angles. And there are four of them. So what is 4 times 90 degrees? Well, 360 degrees. So the four angles of a quadrilateral are all always going to end up adding up to be 360. Okay. Now in a rectangle, they're all 90 degrees. That's not always the case for other quadrilaterals, but that's the easiest way to get you to understand the 360 degrees. Now, talking about types of quadrilaterals. Okay. The first type we're going to look at is a parallelogram. Okay, it's kind of a mouthful, parallelogram, but it's very melodic sounding. Anyway, a parallelogram is a special quadrilateral where opposite sides are parallel and opposite angles are congruent. Okay, so opposite sides are going to be parallel to each other, hence the name parallelogram, but they're going to be congruent. They're going to have the same length. And then opposite angles are going to also have the same measure. Okay. And then you have a rectangle. We should all be familiar with a rectangle. So a rectangle is a special parallelogram. Opposite sides are parallel one another, but all of the angles are going to have the same measure. So all of the angles are 90 degrees like I drew up here. Okay. And then a square is a special type of rectangle. So that means it's also a type of parallelogram. And what's different about a square is that all of the lengths of the four sides are going to be exactly the same. So opposite sides are parallel to each other. Opposite sides are the same length, but it just so happens that the two sides on the left and right and the sides on the top and bottom, they all are the same measure. And then the four angles are all going to be right angles. And then we have a rhombus. Okay. A rhombus kind of looks like a kite. Okay. So a rhombus is a special parallelogram. So we're not saying it's a rectangle or a square. So we can't say that all of the angles are 90 degrees, but it's definitely a special parallelogram where all four sides are congruent. Okay. So it's kind of like a square. So like imagine you have a square and then you like flick its corner and it kind of goes, that's what a rhombus is. So it's kind of like a tilted square. So all of the sides have the same length, but all of the angles don't. Opposite angles are going to match, but not all four of them will. And then finally, we have a trapezoid. The best way I can get you to envision a trapezoid for us older folks, envision like the stereotypical Pizza Hut. Their roof is not a trapezoid, but it has like a trapezoidal feel to it. So that's what I tell people. But a trapezoid is a special quadrilateral where one pair of opposite sides are parallel and the other opposite sides are not. Okay. Now, I do suspect that these definitions will all make more sense when you see a visual. Okay. So let's go through and label all of these pictures. So it says name each quadrilateral, label any congruent sides and any congruent angles. Now, first up, we have a parallelogram. So this right here is in fact a parallelogram. And if you can kind of envision a rectangle, so like part B, we have a rectangle. Imagine flicking that corner that's directly below the B. So flicking this corner like right here, and the thing kind of goes it sort of tilts, then you have a parallelogram, okay? So opposite sides are parallel to each other. So let's kind of label the opposite sides. So like this side that's in this purplish color is going to be parallel to this other side that's in purplish. And then if we take this side right here, it is parallel to this side. So that's what makes a parallelogram. Opposite sides are parallel to each other. And in a parallelogram, they're not just opposite, they're congruent, or they're not just parallel. So opposite sides are parallel for sure, but they're also going to have the same length. So these blue sides have the same length, and these kind of purple magenta sides have the same length. And then we're also told that opposite angles are going to be congruent. So let's do the angles in like green and red. Okay. So this angle here is going to measure this angle here. So we put these little tick marks. Angles that have matching tick marks are considered congruent. So if you can't do colors, you can just use tick marks. Okay. And then this angle here is going to match this angle over here. So I'll put two tick marks in the green ones to show that they match. Okay. So parallelograms, opposite sides are parallel. You can see that the two magenta sides are parallel. The two like turquoisey blue sides are parallel. Opposite angles are congruent and opposite sides are congruent. Okay. Now, a rectangle is what we have next. And a rectangle fits the criteria for a parallelogram. It's just got this extra thing that makes it kind of special. So this is a rectangle. And so we can see that opposite sides are parallel. So these purple sides are definitely parallel. And then these blue sides are parallel as well. Okay. Blue sides are also congruent, and so are purple sides. So that means they have the same measure. So, whoops, don't do that. Same measure. So far we have a situation where we definitely have a parallelogram, okay? But what makes a rectangle special is that all of the angles have the same measure. So all of our angles are 90 degrees. So opposite angles are still congruent. It just so happens that both pairs of opposite angles match each other. So all four angles are 90 degrees. So we have opposite sides are parallel and congruent, and then all of the angles have the same measure. Okay? And that leads us to part C. So in part C, we have black, there it is. We have a square. And a square is a special type of rectangle. And since a rectangle is a special type of parallelogram, a square is also a special type of parallelogram. So we can say that opposite sides are parallel. So I like this one. So we can say opposite sides are parallel and congruent, but they all have the same measure. All right. So all of the sides have the same measure. It's just the top and bottom are parallel, and then the left and right are parallel. And then we can see here too that all of the angles, it's kind of hard to see. Let me do a different color here. That one's hard to see. Let me do like dark blue. All of the angles are 90 degrees. So all four sides are the same length. All four angles have the same measure, and then we still have that opposite sides are parallel. Okay? And that leads us to a rhombus. Let me scoot down just a smidgen. Well, I've got enough room. So this is a rhombus. So a rhombus is it AS, a US? I don't remember. It doesn't matter. So a rhombus is a special type of parallelogram. Okay, so we have that opposite sides are parallel and congruent. But when you're dealing with a rhombus, opposite sides are parallel and congruent, but all of the sides happen to be the same measure. So in this one, let's go back to the purple color. These two sides are parallel, okay? And they have the same measure. But then these two sides are parallel and they have the same measure as the first two sides. So all four sides have the same measure, and then opposite sides are parallel, but the angles we have to be careful with. The angles don't have the same measure anymore. So if we look at this angle right here and the one opposite it, those two angles have the same measure. And then these two angles on the left and right, they have the same measure. So that's a rhombus. Kind of looks like a kite. Okay. And then these last two figures, these are your trapezoids, and they do not look exactly like a Pizza Hut sign, but if I can get people to kind of envision Pizza Hut, they for some reason can see trapezoids. Okay. So when you're dealing with a trapezoid, you have one pair of sides that are parallel. They are not congruent. They are just parallel. Okay. So these two sides, the top and bottom, we call these our bases. So this is base with a capital B. This is base with a lowercase b. And those two sides are parallel. So your bases are going to be parallel. So they're opposite each other and parallel. The other two sides are not parallel. The other two sides are not, none of the sides are really congruent here. Okay. Now, when it comes to the angles, we can't really list congruent sides or congruent angles because none of the sides are going to necessarily be congruent and none of the angles are necessarily going to be congruent. You could certainly build a trapezoid where you have some congruent stuff happening, but this ain't it right here. Okay. So we can't really list any congruent stuff, but we can say that we've got our two bases. And then you can have a height with a trapezoid, and it really is important. It becomes part of your later we're going to talk about like area, and we'll talk about a trapezoid, and height is important. So the height is measured from one base to the next. So you go from one base directly perpendicular to the next base, and that becomes your height. So on a trapezoid that's built like this side on the far left is the height. Okay. It's going to be a little bit different for the next one though. So this is your height. All right. So I forgot to write trapezoid. So this is a trapezoid. Now, the last example is also a trapezoid, and you can see here that no two sides are congruent. So this far left and far right, they're not congruent, they're not parallel. The bottom and the top are parallel, but they're not congruent. So I'm just going to label this the base. We always say the larger or the longer base has a capital B, and the shorter base has a lowercase b. And then if we wanted to represent the height, since the two sides are both slanted, all right, we want to go from just the first base perpendicular to the second base, and that becomes our height. Okay. Now, do I have any more with quadrilaterals? No. So next up, we're going to talk about circles. Okay. So, circles.